Hi everyone. How's it going?
Almost.
Yeah, TGIF, like hard, right? Hard. Game plan for today. Let's go through the optimization set. Take questions from what we did last time. 261. A little bit of test 5 review. We're in and we're out. Sound good? Before I forget, I'm also going to pass out the set 2 for optimization. You just want to take one and pass. And Adrian, when it finally gets to you, if you leave it at that front desk, that'd be swell. Or Mark, if it ends with you, walk it up and put on one of those front desks. Be super. All right. Looking at our optimization problems. Set set. Right. Are we ready? Okay, so the optimal field size there is a 10 by 10 containing an area of 100 square meters. So the dimension would be a 10 by 10 and the maximum area is 100. For 2, our x that maximizes is about 3.92 for a maximum volume of 1,056.31 cubic centimeters ish. Again, those are rounded values because it doesn't make sense in a problem like that to give it as like a radical, right? Like, who measures the length of something with a radical? Like, nobody. Decimal appropriate. 3, our dimension is a 50 by 100, which would contain 5,000 cubic meters. Number 4 is our minimizing production is 100 units for a cost of $400. And then 5, our minimizing production is at 40 units, or sorry, maximizing production is at 40 units, and the maximum profit then is $500. Questions from this? Is there anything we'd like to see done or talk about some more? Number 4. Sure. So it reads, a company produces X units of a product at a cost of C of X equals 0.01 X squared minus 2X plus 5, or 500. And we're asked to find the number of units that minimizes cost. Well, they've given us our cost function, right? So if I'm looking to find a minimum or maximum value, I need to find first the critical points. So to find those, I'm going to calculate the derivative. And then take that derivative and set it equal to 0. And also look for where it does not exist. So where does this derivative fail to exist? Nowhere. Why? Because it's polynomial, right? Perfect. And then this, I'm just going to add over the 2 and then divide by 0.02. Feel good? Okay. Now, I need to pause here for a moment and think about the domain of this function. Because before I start my next checks, I need to know if I'm minimizing or maximizing over an open interval or a closed one. Is okay? All right. What is the x representing in this function? Number of units produced, right? What are the possible numbers of units produced? Got to be positive, right? What do we have here? It's an open interval. So do I need to check endpoints? I do not. I do not. Okay. So to determine whether this is a maximum or minimum, yes, Pete.
How do you know it's an open interval?
Well, because it's like parentheses on either side, right?
Oh, okay.
That's okay?
Yeah.
That's what we mean by open or closed, whether it's parentheses or bracket.
Would it not be equal to 0 as well?
You want to make it equal to 0?
Well,
That's okay. I don't think there's any reason why you couldn't assume that. You just produce 0 things.
yeah.
Mark said positive, and I think either interpretation would be okay. So if it is closed here at one end, what do we still need to check? 0, right? Before I do that, I'm going to do a quick check to make sure 100 is this is a maximum or minimum. So you could do, to check that, either a first or second derivative test. In this case, this thing is so easy to differentiate, I would do a second derivative test. Second derivative is constant. Since the second derivative is positive, we know that x value is a local minimum, or at least it's where a local minimum occurs. I shouldn't say. Yes.
Because negative is maximum?
Yes. Because it's the second derivative, right? So second derivative being positive means it's concave up. So it would look like that. The second derivative was a maximum, be concave down, it would look like that. Right? So that's the way I remember it. It's just like what the shape should be. Okay? So to check then, I'm going to try C of 100 and C of 0. And I'm just going to see which one's bigger. Well, C of 0 is real easy. That's just 500. And then C of 100, we have I have 100 minus 200 plus 500. That's 400. That's the smaller of the two values. So I'd say the minimum cost is 400, and that occurs when I produce 100 units. Does that feel okay? See, you asked about it.
Yeah.
It's okay? Yeah, so again, it's kind of questionable whether you want to think about this as a open or closed interval. Like, it's okay either way, I think.
If we thought about it as an open interval, would it cut any steps that we had to do?
The only thing that it would remove is that check there.
Oh, okay.
That's all you would have. You would have just not checked the endpoint. Which is fine, right? Like, woo, that saved me so much. I didn't really save me much at all, right?
Yeah.
It's a trivial calculation that saved us. Yes, Adrian.
Can you say again what number 1 and 2 are?
Sure.
I
Number one, the dimensions of the rectangle are 10 by 10, so the maximum area is 100 square meters. It's just a square. Hopefully you weren't surprised by that. On 2, the value for x that you're chopping off, the size of the square you're snipping out of the corner, is a 3.92 is the side length of that square, which will result in a volume of about 1,056.31 cubic centimeters. You got a second solution from that you would have discarded. Because it was greater than the domain. That was okay? In general? Again, the optimization one's like, the second set I think is quite a bit more challenging than the first set. Mostly for the first set, I wanted things to be pretty straightforward just so you could get used to the process without having to like have a complicated model to just construct on your own. Here the models start to get a little bit more complicated to build out. It's a little bit more difficult to write the equation, but still like not terrible. Maybe the last one is terrible. Mark? I'm just going to give you 3. What do you guys think? Is this okay? We're going to move on. Did anybody do any of these MCQs that you wanted to talk about? Or did we not get a chance? So I know there's a biology test today. Emma let me know that she did well. She thinks anyways. You want to just do 1 or 2 just for grins and then move on to some 6-1 stuff? Okay. Let's do 3. Well, let's do 2 and 3. We can see them both on the board at the same time. Why don't you guys grab a scrap sheet of paper, try to work through 2 and 3, and then I'll go through them together. Sound good to you guys? That gets you a little bit of practice in. We have, 10 minutes or something to spare here. Give you a chance to practice. We'll go over them and then we'll move on to 6-1. Which is a fairly easy section. I'll get mad at me when we get to 6-2 and 6-3, but 6-1 we should feel pretty good about. Bonus if you can do it without actually doing the process, if you can look at the multiple choice and know the answer. Yep, that's okay if you can't. I'll explain to you how I can look at it and know the answer without actually doing the problem. But I think until you grind it through some of these to get a feel for how these are going to work, it's an unreasonable expectation that I would be able to ask you to do this straight from jump until you've done some practice doing the process, doing the computation.
So you don't need to go into the whole
I can do that for 2. I can't do it for 3 though. 3 I would have to do myself. Whoever wrote the answer, possible answers for 3, did a better job than they did on 2. Yeah, go ahead. Hopefully everybody recognized on number 2 that we need to start with the synthetic division. Two times 8 isn't 24. Yes. There we go.
Assuming there's no questions on it.
So let me explain to you how I did this without actually doing it. I saw the start degree of the numerator bigger than the degree of the denominator. Knew I was going to have to do division to do that. If I divide a quadratic by a linear term, I'm going to get a linear term plus the remainder piece. So the integral of a linear term should be a quadratic term, and the integral of a, like constant over x or constant over linear is going to be a natural log of something. Quadratic, natural log of something. It's the only one that has those 2 pieces in it. So I knew, without having to actually go through the process of integration and doing all that mumbo jumbo, that it had to be 8. Because it was the only one that had a linear or a quadratic piece plus the natural log piece. Now, until you've done a bunch of these and kind of get a feel for those patterns, tough to see that right off from jump. But those sorts of thought processes are the way you would finish the multiple choice sections on the AP exam. Because you're able to recognize, like, oh, this could be a 2-minute question that I can reduce down to a 10-second question, which gives me time to bank for something that I have to figure out how to do, or a problem where it's like you have to find the maximum minimum of something where it's just like, this is just a long problem, no way to cut it, because I have to take the derivative, set it equal to 0, solve that equation, take those possibly with endpoints and possibly with other critical points for where it's undefined, and then check all those things, like it is a lengthy process. There's no way of getting around it without a calculator. So like finding ways to like pick up a couple minutes here and there are really helpful. Any questions on 2? Do you guys still need a minute or 2? Are you still working on 3? Did we at least get to the point where you're trying to start your partial fraction decomposition? Do we recognize that that was the technique here? I'll say that at lunch and then give you guys another few minutes to kind of see if you grind to the end. Lucy. So I know that when I add the x terms, they have to add up to 3x, right? So a plus b has to give me the 3. Because those are the coefficients on the x terms. Is that good? That's where that equation comes from. And then that's where that equation comes from. And I just solved the system, and it was set up nicely to do with elimination. They're very kind to us there, where we have to multiply through by another constant or whatever. I get to add straight down. And then the integral piece. The only question for me after I factored it was like, what will these coefficients be? Because everything else is the same natural log of factors. I just had to figure out which one of these numbers went with the x minus 3 and which one had to go with the x minus 1. So I stopped. I didn't even bother with the integration once I got to this point because I saw it was like the 5 is with the x minus 3 and the negative 2 is with the x minus 1. Okay.
So the negative 2b plus 4, then b plus negative 5. Is that from using the matrix?
I just did it in my head. Like I just did this, added the 2 down.
Yeah.
So negative b is equal to 4, and then divide both sides by the negative 2. And then I plugged it back into this equation.
Yeah.
And just solve for the a. Well, I assume this is a no calculator problem because it doesn't indicate that there would have been a calculator active question. But you could certainly do that if you had a calculator available to you. You could solve that system with a matrix. Absolutely, yes. I did it just by elimination because it closed. You know, I assumed it was closed at this point. Everybody feel okay? Let's go and look at section 6.1. So in chapter 5, we talked about integration, and we talked about one way of conceptualizing integration is it's like the area under a curve, right? Between the curve and the x-axis. So sometimes that the curve was below would be the area above the curve, and sometimes the curve was above the x-axis would be the area below, or sometimes if it crosses it would be, some of each, right? What we want to talk about today is the area between two curves. So if I want like this guy here, so this is the area between f of x and g of x between a and b, right? So if I think about this, okay, well, if I think about this as like a Riemann sum, I have like this part is like related to the integral of f, and this part is the integral of g, but I want to actually, this is a negative area, I want to make it positive. So I'm going to take these slivers and I'm just going to take, this negative height of g and subtract it. And that'll make sure it's giving me a positive area. And if I do that for infinitely many of these little slivers, I get something like this. And what should this look like? An integral, right? If I have the sum of infinitely many rectangles, that's all we're talking about here. I get an integral. And so this is our integration formula. The integral from a to b of f of x minus g of x dx. Make that bigger. Sorry, it was small. You guys should have yelled at me before that my guy's pointing at something that's too small for you to see in the back. But that's our formula for the area between two curves. Now, notice that there's a condition here. What's the condition to use this formula? That f of x is always greater than or equal to g of x on the entire interval. What's going to happen if they cross and they switch which one's on top and which one's on bottom? We're going to have to find the x coordinate where they switch and break our integral into integral of f of x minus g of x plus the integral of g of x minus f of x. That's typically the trickiest part, is recognizing that, ooh, no, they switch. Okay. And I have this question. What happens if g of x is just a zero function? What does this formula turn into? Just the integral of f of x, which is the area between f of x and the x-axis, right? Oh, yeah, sure. It just turns into what we've been doing before. So let's do an example here. Find the area of the region bounded above by the function y equals e to the x and bounded below by the function y equals x, and then bounded on the sides by 0 and 1. Now they've supplied us a picture, so it's really easy to see which function is on top. E to the x the entire time, right? So I have that. That's my integral. Everybody happy with how we wrote that? What's the antiderivative of e to the x? E to the x. What's the antiderivative of x? Yep. Or x squared over 2. That's fine. And we just evaluate from 0 to 1. There's my answer. Very cool. See where the 3 halves come from? E to the 0 is 1. Negative a half minus 1 is negative 3 halves. No big deal, right? Is this much different than what we've been doing in terms of like evaluating an integral? No, man. It's pretty straightforward. Okay. So let's say we want the area of the region enclosed by the parabola x squared and 2x minus x squared. Now, we've been supplied a picture here, so you can see where the two intersect. What if you didn't have that picture? this wasn't here. What if you didn't have a calculator? You just set them equal to each other. Yes, you should. Yes, of course. Sure. Everybody good with how I did that? Just a little bit of algebra 2 stuff there, solving a quadratic. Maybe that's even algebra 1. That's pretty easy quadratic to handle. Now, if I think about which one's on top and which one's on bottom, that should be easy. What's y equals x squared look like? What does 2x minus x squared look like? Downward facing parabola, right? What does one of its x-intercepts have to be? 0, and the other one would have to be 2, right? Everybody agree? Easy enough to see that. So which one's going to be on top? This guy. Everybody good with the setup then?
Is it 1 to 0? That's the...
Yes, that was where they crossed. Exactly. Or where they meet. So I'll combine those x squareds. And then we're just doing antiderivatives. Okay there? So far so good, right? It's fairly straightforward. Pretty easy concept. Okay. Notice here again, they gave us a picture, but what did they neglect to give us this time? The actual intercepts, right? How did we find the intercepts again? Where the graphs cross? Set them equal to each other. Woof, guys, how are we solving this? I think the best option would be doing this. That'll get rid of our square root. What do we have to do on this side, though? Yeah, we have to FOIL that out, right? Oh, thank you. Yes. It's getting pretty nasty, guys. What am I going to have to do next? I'm not, well, you could, I wouldn't. I'm more concerned about this fraction here and getting rid of that. Yuck. So I'm going to have x to the 10th plus x to the 8th minus 2x to the 7th minus 2x to the 5th plus x to the 4th plus x squared. Subtract the x squared from both sides at least. And I can take out a x to the 4th. Oof. Don't love how this is going. Oh, I see what they would have wanted us to do here. I've made a reading error. Approximate means that we're going to be needing to use our calculator. So I would not want to do this algebra. I'm going to retract that. Nothing that we did was incorrect, but we got stuck with this polynomial at the bottom that I don't know that we're going to be able to solve. Looking at it, the obvious choice is to try doing synthetic division on. 1 and -1 will not work. They don't give me a 0 remainder. So I'm just kind of at an intractable point on that. Maybe there's some clever kind of factoring, but I don't see it. On how to get there. Rather, we would have just taken our initial piece there. We got the x equals 0 at least. And just use our calculator here. So I have x over square root x squared plus 1, and then x to the 4th minus x. And then I'll just, I don't know what the last thing I graphed, I'm just going to zoom standard that. And then we just find our intersection, enter, and the one I'm interested in is this guy over here. So 1.18-ish. Now, since we're doing this on the calculator, right? Emma? Sure, you're gonna miss the seesaw. Good thing though on the calculator. Since we're doing this on the calculator, I'm gonna do the integral on the calculator. Okay? If I have the calculator to do the graph and define the bound, I'm not gonna do the integral by hand. I'm gonna use the calculator to do it, right? And I don't even care about which one's on top and the bottom if I have the calculator. Why don't I? I'm just going to do an absolute value. If I do an absolute value around the whole thing, it doesn't matter which one's on top and which one's on bottom. Who cares? The calculators can handle the absolute value just fine. It's a pain for us to do by hand, but the calculator doesn't care. So I'll do that. And this is going to get kind of messy to type in. So what I'm going to do, I've already saved these guys into y1 and y2. So math, fn int 0 to 1.18. Then to get the absolute value, do math, go over to number, absolute value, and then I'm just going to do y1 minus y2. I don't want to type those things in again. So vars, y vars, function y1 minus vars, y vars, function y2, and then dx. I'll let the calculator handle the whole thing. If I have to calculate, if I need the calculator to find the interception or the intercepts or the intersections, I have the calculator do the integral. And rather than worrying about making sure which one is subtracting which, if they don't cross, just absolute value the whole thing and it'll be fine. Everybody happy? Oh no, what if one curve isn't always above the other? So from here to here, we should have f minus g. From here to here, we'd have to have g minus f. And then here again, we'd have f minus g, right? Everybody agree? So this integral would just, or we just break this into 3 pieces. So I just do something like that. Or, if I have a calculator, just use the absolute value and be done with it. Much easier, right? Okay. That's what we have. So again, the area between the two curves is just the integral of the absolute value of their difference. Doesn't matter if they flip and flop or you have one on top or one on bottom. Notice there's no conditions for this. I do not need f of x greater than or equal to g of x. This works regardless of which one is on top and which one is on bottom, or how many times they switch being on top or bottom. The only downside is, to do it by hand, means I have to do this. So let's do that as a practice. Sound good? All right. So it says, find the area of the region bounded by the curves y equals sine x and y equals cosine x from x equals 0 to x equals pi over 2. Now, I've supplied the graph for us so we can visualize what's going on. If there was no graph, the first thing I do is I have to set these two things equal to each other to make sure they don't, to see if they intersect or not. If they don't, I have one integral. If they do, I will have multiple integrals. Everybody good? How do I solve sine x equal to cosine x? It's a pre-calculus question.
Divided by each other, so you can't change.
Yeah, so I'll divide both sides by cosine x. So I have sine x over cosine x is equal to 1. That's just tangent x. And then we do tan inverse to both sides. So I have x is equal to tan inverse of 1. Oh, God. And then between 0 and pi over 2, tangent is equal to 1 at the 45-degree angle for pi over 4. Again, is the expectation of the IB that you can handle unit circle angles in your head like that? Okay. So how do I know which one's on top and which one's on bottom? What's cosine of 0? 1. What's sine of 0? 0. Which one's on top at the start? Cosine. And then at pi over 4, they're going to have to flip, right? Because at pi over 2, cosine is 0 and sine is 1. Does everybody feel okay with how I set this up? The derivative of cosine is? I'm sorry, the integral of cosine is? Is it negative or positive? Positive. Because if I take the derivative of sine, I should get cosine back. The integral of negative sine is? There's a negative sign there. Positive cosine. Right? Or you could think about it as like this if you want to. Either way is fine. And that's from 0 to pi over 2. And then the integral of positive sine is negative cosine. And the integral of negative cosine is negative sine. And that's from pi over 4 to pi over 2. So sine of pi over 2 is 1. Cosine of pi over 2 is 0. Sine of 0 is 0. Cosine of 0 is, so what am I going to get here? Okay. Oh my God. This is supposed to be pi over 4, dum-dum. Right? I wrote it there. Ay. All right. Sine of pi over 4 is root 2 over 2, right? Cosine of pi over 4 is. And then we have sine of 0 is 0, and cosine of 0 is 1. Okay, there we go. Everybody happy? We'll do the same thing over here. Cosine of root 2 over, or cosine of pi over 2 is 1. Oh no, sorry, yeah, it's 0. Goodness gracious. And sine of pi over 2 is 1. There we go. And then minus negative cosine of pi over 4 is, and then positive or negative sine of root 2, and that's the same thing, right? Okay, so we distribute these things through. I add these two together. What do I get? Or just root 2, right? Okay, and then I have minus 1. And then I have minus 1. And then I have a positive root 2 over 2, or positive 2 root 2. So this would be 2 root 2 minus 2. Everybody okay with that? All right. What if instead of looking for like the vertical area between the two curves, what if we're looking for the horizontal area between the two curves? Okay. It's the same idea, just now we have to rewrite this in terms of y instead of x. So essentially what we're doing is we're like solving for y to create an or solving for x to create an expression in terms of y, We're going to use those expressions to integrate. But it's the same idea. Instead of top minus bottom, it's going to be right minus left. Is everybody okay with that? So let's take a look here. Yeah, for sure. Switching the variable will be quite common. So it says find the area enclosed by the line, y equals x minus 1, and the parabola y squared is equal to 2x plus 6. So what I'm going to do is I'm going to notice this guy, I have to do plus or minus the square root of 2x plus 6. I don't have a good way to, like the u sub for that looks pretty crummy. How do I deal with the plus or minus? That all seems like kind of a nightmare to me, right? So instead what we'll do is I'm going to rewrite both of these in terms of x. Okay, with that. I'm then going to find where they intersect by setting them equal to each other. I'm going to clear the fraction, so I'll multiply both sides through by 2. And I have a quadratic, so I'm going to move it all onto the same side. I'll solve this quadratic. Is everybody okay with that? My last question here is going to be which one is on top and which one is on bottom. So to do that, all I'm going to do is pick a value of y in between and plug it in to see which one is bigger or which one is further to the right. So what value of y seems like it would be really easy to handle? 1, -1, 0, all of those would be good choices. If I plugged in 1, I have 2 here, and I have -5 over 2 there. This one is my right function, and this one would be my left. Since 2 is bigger than 5 over 2, the x value is further to the right, because we're finding an x. Oops. Right? X equals 2 is further to the right than x equals -5.2, or 5/2. You guys okay? So we'll integrate, oh boy, what just happened? We'll integrate from -2 to 4 of y plus 1 minus, and I'm going to write this as just 1/2 y squared minus 3, just to make my life a little bit easier. Everybody happy? I'm going to distribute through that negative sign and combine some like terms, and I'm just going to write this into like standard form, so it's a little bit easier to just, when I do the antiderivative, it'll just be a little cleaner for me that way, I think. So what do I get? I get -1/2 y cubed over 3 plus y squared over 2 plus 4y that we evaluate from -2 to 4. Now just plug in stuff, right? 4 cubed is 64. Divided by 2 is 32, so I have -32 over 3. 4 squared is 16 over 2 is 8. And then 4 times 4 is 16. And then I have -2 plugged in, so I have -2 cubed is 8. And then times a -1/2 is +4. And then I have Negative 2 squared is 4 over 2, that's just 2. And then that's negative 8. So if I bring this through, that's going to be negative 36 thirds. And then that's 24. Minus 2 is 22. And then plus 8 is 30. And that's going to be negative 12 plus 30. So I should have 18. Just arithmetic in my way through there. So the takeaway here is this area between two curves, you can do left and right, you can do up and down. Doesn't matter. If you want to do left and right, you have to write them in terms of y. So you have to get the x by itself, a little bit of algebra. That can be useful, particularly when you have something that's where there's something attached to y already. Right? If you have a y squared or y to the third, like, I usually don't want to try to get the y by itself in those cases and deal with the hassle involved with dealing with plus or minuses when integrating. That's kind of a nightmare. I don't want that. Is that okay with everybody? That's it for 6-1. That's the idea. Area between two curves. Relatively simple, right? At least as far as AP calculus goes. I know, like, that was not trivial that what we just did, but it's not like a big step forward from what we've been doing. Am I right? Felt very much in the vein of what we've been doing. Okay. You want to do some test 5 AP questions here? Does anybody have ones in particular that they looked at and were like, yo, what? How do I do this? If not, I will just randomly go through and pick stuff. You guys just want me to pick?
Yeah.
Okay, that's fine. I don't know what you guys have been able to get to, how much preparation you've started. Sounds like a lot of zeros. Let's see. We did this, right? We practiced doing these kind of things, converting between the Riemann sum to the integral. Should be able to do that. That's not what I'm looking for. Now let's do this. So this is a calculator question. Once you try on your own, I'll wait for a couple minutes and then I'll go in and start solving stuff. How's that sound to you guys? Of course I can. Is that better, Aaron?
Yeah.
Yep. I just want to leave the choices on there also. We are in set 2, version 2, MCQ, test 5 MCQ version 2. I don't know,
Calculator problem.
This is a calculator problem, yes. And my suspicion is that you'll have to have the calculator to do it, because I don't think you'll be able to solve the derivative equal to 0 without it. But you might. Oh, actually, looking at what the numbers are, I think you should be able to. But who's got the derivative of this? It's a chain rule. I want to take just a brief minute and at least talk about why I know that this derivative is always defined. What's the domain of e to the x? All real numbers. The domain of a polynomial. So this derivative is defined for all real numbers, right? Hey. Because we're looking for a minimum, right? So we want to start by finding the critical points. So we take the derivative and set it equal to 0, and where the derivative doesn't exist. Is that?
Yeah.
Okay. What's the solution to this? You should be able to do that in your head. Doesn't exist. Why? If I have an exponential function, if I have just an exponential term, it can never equal 0. Now, it's tempting to circle this right away, right? But we also have that as an option, because it's possible that this critical value is neither or a maximum. It doesn't guarantee that it's that. So I still need to check to see if 3/2 actually works. What should I do to check it? I would probably do a second derivative test here rather than a first would be okay too. You could do a first. The disadvantage of the second derivative test is I have to get rid of this thing again, which involves product and chain rules. Maybe a first derivative test might be a better option here. Okay, if I plug 1 into this piece, I got to get what kind of a number to come out? Positive or negative? It has to be positive, right? It's an exponential function. I can't make it negative. Oh, that's nice. If I plug 1 into here, I get positive or negative? Negative. Positive times negative is? Okay. I plug the 2 into here. For this piece, I get? For this piece, I get? So we've gone from decreasing to increasing. That is a minimum. Sure. So if I think about this, this is really f of the integral from -2 of g of x e to the t squared dt, right? So the derivative then should be e to the f of x squared times the derivative of fx. Oh, I missed a thing here. That's okay. It would have been like, no, that's fine. Yeah, that's exactly right. That's exactly right. Does that feel okay, Mark? Okay. Because really what we have here is like f of g of x. Okay. So far, so good. On to another one. The same point as that one. It's probably a good one. Let's do this. Similar question, right? Just presenting you with different starting information. Instead of getting a function, you get a graph. And there's another important wrinkle going on here that makes sure you read. Who's got the answer? What do we start by doing? We're looking for a maximum or minimum. We need the derivative of g, which is f of x, right? We set that equal to 0. Now we know f of x is defined everywhere, right? So we don't have to worry about where it does not exist, because we can see the graph is defined for all values. Where does this equal to 0? At 3. Is that all we have to check? What else do we still need to check? Well, we don't need to worry about that because f of x is, I mean, we can check, but I'm just checking right now. Like the function is defined, f is defined for all values of x on the interval we're solving on. What type of interval are we looking in? Closed. So what else do we have to check? We also have to check the endpoints. Everybody's okay? So I need to check then g of 0, g of 3, and g of 6. So that's that, right? What do you notice about that integral? Look at the bounds. They're going from big to small, right? We don't like that. That's -2. Or 4. Sorry. Are you happy there? I just computed the area of this square, just using geometry, right? So here we're going from 2 to 3. There, we are small to big, right? Oops. So I'm just looking for this area. 1/2 base times height, because it's a triangle. And then for g of 6, that's formatted properly. So I'm looking for this area. Now I noticed that. Stop. That those two sections are going to cancel each other out, right? So I'm just left with this piece below the x-axis, x -4 also. So which one of these is our maximum value? This is one of those that, like, it just is going to take some time. You can't really look at it and do it automatically, especially because you're starting at 2 instead of 0. If it was at 0, then yes, you could do it with just looking at it. It would not be hard. The 2 really puts a monkey wrench in the thing. Does that feel okay though? You see how it was the same problem really as the previous one, just a different presentation. But the steps were ostensibly the same thing. Gonna skip that. Let's do this one. Aaron, I can't really make this much bigger and still fit the answers in at the bottom, I'm sorry. The graph of the function f shown above consists of 2 line segments and a semicircle. Let g be defined by g of x equals the integral from 0 to x of f of t dt. What is the value of g of 5?
Today's a review day, so comment questions.
Anybody got it yet?
The government, if we can lower our voices, someone's got a very important question. Crowding out is the fact that the government is demanding more loans, which takes away the supply of global.
Look at you guys. Again, if all you're given is a graph and you're asked to compute an integral from it, you've got to be using geometry. There's no other way to do it. Right? Everybody happy? I'm going to look for one more. I'm looking for one specific one. I think it was up here in the beginning. I don't remember if it was in this set or the first set, but there's one that I wanted to for sure look at real quick. I don't know if we did it or not, but I want to make sure that we do it. It said do. Is it? Thought I had it. Yeah, here we go. Calculator problem, note. And this is one that it cannot be done without it. Your hint is that you'll use the fundamental theorem of calculus part 2 to do this problem. Which says that says that. Where cap f is the antiderivative of little f. So you set it up using the fundamental theorem of calculus, and then you have to knock out that integral using your calculator, and then just a little bit of algebra to get the g of 1 by itself. I don't remember what this works out to. I want to say it's this guy, but I'm not positive. Let's cheat real quick, huh? This is 14. Yeah. Oops, do that. Hey.
Why do you have a calculator? Why can't you just do plug in 3 and do that? The function.
What's the antiderivative of the square root of x cubed plus 2?
Or,
Can't use sub it because of the x cubed. Because there's not a 3x squared left over term. So you could use, I don't even know that this is one that's even tractable, even if we go and do the third substitution. I don't think this one that's going to be doable. I think this is one where, like, there is no closed form where you're stuck unless you recognize the cap. Is that okay?
yeah.
Mark, what's up? Oh, okay. Stretch on, brother. So, just for the record, if you try doing this as a u sub, I have the dx, but there's no way to get rid of that x squared. Trying to do a u sub, like you just can't get rid of it. Can't do it. I can't tell without trying a little harder if you could trig substitute that one out, but it doesn't look like a good candidate for it.
Which one?
Square root of x cubed plus 2. It doesn't look like a trig substitution problem to me. Or a good candidate
No, it's not, because you can't have the cube.
Yeah.
And the 2 isn't one.
The 2 is a problem as well, yeah.
They're both not good for it.
Yeah.
Yeah, I mean, you probably have to do a substitution by parts if you're doing it.
I don't think it'll work.
By parts?
Yeah.
Why not?
Well, what's your first part? One of your
Oh,
parts.
no, you can't do parts.
Yeah.
It's not multiple.
Well, you mean only if one of the parts can be dx, right? Like, then that has to be the thing you're integrating. But I don't think it's going to work out either. I think you're going to be left with.
You have to.
I think it's a calculator only problem. I think the person that wrote this is smart enough to give you something that's intractable.
But you can still do it with a calculator.
Yes. Yeah, I mean, you just
Have a good weekend.
you just type it in your calculator, press enter.
Yeah. And I'm
It just
sure.
approximates it.
Yeah.
But